Okay, so linear regressions is the same thing that we just finished doing. Linear regressions are used when you don't have the equation of a line and you want to get the equation of that line. And we can be doing line of best fit. So the linear regression, what is it? It's a line of best fit for ordered pairs, for scatter plots, or for anything that you have that looks like it could be a line. Or okay, so that, once you have all these points, like this table, if you have all of those points and you want a line, an equation of the line for that scatter plot, then you can do the line of best fit, the linear regression, by doing y1 approximately m of x1 plus b. Okay, and because we use decimals now, we don't need this part. This is on a TI calculator. You can use stat to get the equation. We don't need it anymore because now we have decimals, and this is what we do in decimals. So I'm going to do problem number 1, and then you guys are going to do the rest of them. It's going to ask you for a few things. It's going to ask you for the line of best fit for those points. So we would put those in decimals on a table. We would do the linear regression and get the equation. And then it's going to ask you to estimate the for any point. But I also want you to tell me the R, which is the constant of variation for that table. Okay? So we're going to do all of that, and then I'm going to tell you in a little bit what R actually does. So let's all put this table in decimals, and let's find the line of best fit for it. So again, you're going to add a table. Everybody's doing this. We're doing it together. You're going to do the x's first. So, Miss Mesa, which one are the x's? The top is the x's and the bottom are the y's. So I'm going to type 0, 10, 20, 30, 40, 50, 60, 70, 80 first, and then we're going to do the whole bottom line. Okay? So, 0, enter. 10, enter. 20, enter, and it starts giving you the pattern. So you don't have to keep typing it, just keep pressing enter, 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 enter until you get to 80. Okay? On the other side, you have 79.2, 80.1, 77.5, 68.7, 57.4, 42.4, 30.0, 12.7, and 1.0. So look, it plotted all of your points, okay? And to me, it looks more like a quadratic, but it's asking us for a line of best fit, so we're going to get a linear equation, not a quadratic equation. So down here, we're going to add the linear regression, which is y1 approximately m x1 plus b. Okay? Now, if your graph is not zoomed out, you can zoom out. Mine was already zoomed out. That's why I can see all the points and the line. So right here, it gave us an M, it gave us a B, and it also gave us the R that I was telling you about. So let's write that down. I have negative, and I'm just going to round. This is negative 1, right, because it's 0.06, so I'm just going to say negative 1.1 x plus 92.3. So y equals negative 1.1x plus 92.3. What is the r? What is the r? What did they tell us r is? It's right here. Negative 0.97. Negative 0.97. So let's write that down. Negative 0.97. Okay, and I'm going to show you what the r does. So this is the constant of variation, the correlation coefficient, and these are the differences. As the number gets closer to 1, the more perfect the line is. As the number gets closer to 0, on the positive side, the closer to no correlation, right? Same thing to the other side, the closer to negative 1 that it gets, the closer to a perfect negative correlation, and the closer to 0 it gets on the negative side, the closer to a no correlation. So the number that we just got, hold on, the number that we just got on our constant of variation, let's change this to correlation coefficient because I like it better. Correlation coefficient. Correlation coefficient. We got negative 0.97. That number is really, really, really close to what number? To negative 1. Okay? So that number is really close to negative 1, meaning it's really close to looking like a perfect negative correlation. This is what it would look like, and we know that that's what it looks like because now we have Desmos, and Desmos shows you that it's almost perfect. Okay? So for all of these problems, I want the line of best fit. I want the correlation coefficient, which is the R for every problem, even though it's not asking it, I'm asking it. And then we have to answer the question that it gives us. It says, estimate the average temperature for a city with an altitude of 25 degrees. So 25 degrees would be somewhere right here in the middle of 20 and 30, right? So it would be somewhere in the middle of 77.5 and 68.7. But if you want something perfect, like a perfect number, then we're going to type 25 in Desmos. So right here, I'm going to type, no, on this one. Let me see if it'll do it. It probably won't. No. So we're going to have to type this equation, the equation that we just wrote down. Right here, y equals negative 0.1 x plus 92.3. And we're going to do the settings. I want the table for it, and I want to know what happens at 25, because that's going to make the prediction of where it's going to fall in. Okay? So my prediction is that if the city has an altitude of 25 degrees, then it's going to be 64.8. So let's write that down. Degrees Fahrenheit, because this is the latitude and then this is the temperature. So if our latitude is 25 degrees, then our temperature will probably be 64.8 degrees Fahrenheit. Okay? So again, you type the table, you find the line of best fit, you type the line of best fit in Desmos so that you can go make predictions for whatever numbers they're asking you for. Okay? For problem number 2, don't go typing 2012 because that's not a thing. Okay, they're telling you that they started at 1980. That means that year is 0, year 0. So how many years passed from 1980 to 2012? How many years passed from 1980 to 2012? Do 2012 minus 1980, and that'll give you what year this was. Did y'all subtract already? Are we subtracting? 2012, 32 years. So we're looking what happened at 32 years. Okay? So you guys are doing the rest of them by yourself. Don't forget the correlation coefficient for all of them.